So to close out our chapter on lighting and illumination, just to drive home a couple of the terms and concepts that we've discussed and add a few more in, this idea of color rendering index that I've discussed about the choices of bulbs, where I mentioned that like a fluorescent bulb has a poor color rendering index. We have this idea of measuring color temperature in degrees Kelvin. So we have direct sunlight measured at 4,800 degrees Kelvin. Um, the light coming off of a clear blue sky is being at 10,000 degrees Kelvin. And so we have this gamut of those being the references that have the best color rendering index, clear blue sky, to those things that have the poorest color rendering index, which would be a sodium high pressure bulb or a candle, a room candle. And what our standards have been up to this point have been incandescent lighting, the kinds of filament bulbs that get very hot, having 2,800 degrees Kelvin. And now we have interstitially in this whole realm, we have now LED bulbs available to us with color in the color spectrums to meet the demands that we would have. For instance, if we wanted to meet the incandescent type of warm lighting, we could use a warm LED bulbs. If we want to have good color rendering index, we can use the natural white LED bulbs. And if we're really concerned about critical lighting, we can use even higher color temperature bulbs, LEDs. But there's always a trade-off into this idea of the bluish gas, and some people will respond actually poorly to interior scenes that are lit too coldly, so to speak. So this idea of color rendering index is kind of reflected here in this graphic. I thought this was very useful. So here we can imagine this scene on the left being lit by incandescent bulbs, casting off a warm yellow light. Actually could be considered very attractive. But what we see when we compare that to something that has a more white or better color rendering index lighting system to it, is this ability to help us differentiate the colors of the object. So you'll notice if you can do an A and B comparison and look at things like the Tiffany style lamp cover, you can see how the colors pop and they read well. The blues are no longer buried into the warmth of the scene setting. You can see all of the detail and the color lighting here. So this goes to this idea of high color rendering index light sources give us this kind of better ability to distinguish in interior environments color contrast and color differentiation. And in some cases that may be undesirable when we're trying to create mood lightings or certain kinds of effects. Some basic terms we need to have in hand: this idea of refraction, the idea that when light goes through a transparent material, the light is refracted or bent. It's always described with this idea of a pencil going through the water and how the light is refracted as it passes through. And this is a really important concept, this idea of specular and diffuse reflection. Especially important because we model our scenes and we want them to accurately be portrayed as they really are. So this idea of specular reflection is light hits a surface that is very smooth, and the reflection is a very accurate portrayal of what struck the surface. So in this case here we have a specular reflection of this building on a glassy lake with no irregularities in it, and we see a perfect reflection of the building as if it was a mirrored surface. And then we have a diffuse reflection, which is the idea that now the light is reflected off. There's wind has disturbed the surface, it's now a diffuse surface, and we get this diffuse lighting scheme coming off of the surface. This is really important for us to create this idea of specular highlighting. And it helps us to understand and read materials that are in the space, read the quality of light, and create senses of realism. So here we have this idea of different kinds of lighting systems and the idea of specular reflections coming off of them, creating this illusion in the modeling lighting scheme of this being the surface being smooth and having a reflecting covering over it. portrayed out in the real world of things that we would be illuminating. I thought this was a good example of showing you where specular reflectivity is really important. So here we have some under-counter lighting and some objects placed in the room. And I've gone ahead and kind of highlighted some areas where you get the concept of specular reflection. So here we have a rounded handle, and we can see that we're reflecting what was probably a window over here on this, creating a highlighting surface on this reflective material. You don't see it on the diffuse surfaces because there's not enough smoothness to reflect an accurate portrayal of that light. And you don't see it on all the objects, but you always see it on ones that are shinier. So here we have a shiny surface to this pepper, and we can start to see specular highlighting. And you can almost see this as a reflection of what's over here, whether we're seeing the reflections of windows here. Over here we're seeing the reflection of that under-counter light on the edges of this object. So we're actually just seeing 3 reflections of that single light there. We see these same kind of highlights here on the top of the red pepper. We see the proximity reflections of the light, the green light, yellow light coming off, reflecting on the reflective metal surface over here. And we see those same things on these other specular surfaces, which glass is one of them, the most popular. So we have this nice tight reflection on the glass and a little more diffuse reflection on the brushed stainless steel lid for it. But all of these all of these are important in convincing us that the scene is realistic because this is how objects actually respond to light in the natural environment. And also, in order to get these specular highlighting, which is also very pleasant to look at, the idea of paying attention to placements of light sources and the reflections that will come off of them. So here we have a good example of that with tile. We have what looks like, if you see it, there's a window over here. We can see each one of these is an individual reflection of that window surface, or that what may be a softbox because it's professional photographic lighting. But it helps to communicate to us that these surfaces are both reflective and also curved and glass-like. And here we have another just typical example of glassware, and you can see that compared to these textured or non-specular diffuse surfaces below. So now we're seeing accurate reflections in the glass of things that surround it. So enough on specular and diffuse reflection, but materials have coating systems on them that control how much light gets reflected off of them. One of the most important, so these are some general charts. So we have reflective for landscapes, for use of the materials that we might place in a landscape. Many times we're discussing this idea of reflectivity on the exterior to reduce the amount of heat that gets formed on surfaces. It's called the heat island effect. So if you painted a surface black outside, it would get very hot. Obviously, if you painted it white or reflective, it would stay cooler, and that can make us give us a sense of control over the comfort of an exterior environment that we may be trying to utilize, and or overall in general in reducing heat island effects in cities. And in the interior, we have reflective surfaces many times to reflect light around, as we discussed in the like shelves, painting of ceiling surfaces and other interior surfaces. But these are some of the reflectivities of those kinds of materials. In this case, roofing materials. Really important to get the most reflective materials possible to reduce the amount of heat that's retained in the material that strikes, that the light strikes. Our eyes are very much like camera lenses, so, well, very like, that's probably a bit of an exaggeration, but we do have this idea of rods and cones. Cones are receptive to colored light, rods are see in black and white, but they're ultra sensitive to light. So in low lighting situations, we create hypersensitive neurons that allow us to see in very low lighting situations. Many times our eyes see much better than our photographic film does. And we also have the ability to create an aperture of our eye with the iris to control the amount of light entering our eye, just as happens with a camera lens. And one of the interesting things that happens as the aperture gets smaller is the concept of depth of field. So when the eye is open very wide, or camera lens is very open very wide, The foreground, if it's focused on, is very sharp, but the background can be very blurry. In the case when things are brightly lit and the aperture is shut down very tight, the depth of field is very deep, so everything stays in focus. So this idea of being able to control that aperture, depth of field is important, especially when we're trying to create high quality renderings in model space. So that was just the overview of our requirements for just the basics of understanding lighting, and the start into the project that we're going to do. Like I said, we'll create a building, we'll modify some windows, create some light shelves, do some luminance rendering, and do some ray traced rendering inside of Revit, which I outline in the video series. And I invite you to follow along with it either directly, or if you feel so inclined, if you can meet all of the metrics, so to speak, of the techniques that are required, you can really make the format of this model and the interior spaces to anything that you find useful or engaging for you. So good luck.